Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Okay, well, welcome. Today we have with us Flavio Brazil. Welcome, good to have you.
Great, thank you so much for the invite. I've been listening to your podcast for a long time, so it's nice to be here now and talking to you.
It's a privilege to have you on.
Yes.
Before we dive in, we
Yes.
have an update on Winter Tech Forum.
Right. It looks like, now I haven't completely got the finalization from the hall yet, but it looks like the last week of February. So
Awesome.
So it would end March 1st.
Okay.
And
what is the Winter Tech Forum for anyone
the Winter Tech
new
Forum
to
is the
this?
conference that we hold up here annually, and it used to be
Up here in beautiful Crested Butte,
Colorado, where it looks like there's going to be a lot of snow this year, so people who want to come up and ski can do that. But we've been holding a conference. It started out as the Java Posse Roundup, and then eventually the Java Posse got tired of doing their podcast, and so then we changed it to the Winter Tech Forum, WTF for short.
Yeah.
And then eventually we figured out how to do a podcast ourselves. So
Yeah.
that's the full cycle. But there's a website, wintertechforum.com. I don't have this year's dates yet because I'm waiting for the hall. But the last I heard from them, it sounded like that would work. So.
Cool. And it is a unconference. Well,
yes,
it's an open spaces
it's
style
open spaces.
Conference.
Yeah, unconference has got kind of a different flavor to it at this point. But yeah, so we don't have speakers, but we have discussions, and we see
lightning talks
and hackathon days, and on Sunday it looks like there'll be a ski out to the yurt for the brunch there, and all kinds of activities. So generally when you're here, it's not like conferences that you go to where it's like, oh, well, the official conference is over, you're on your own. It's like we're kind of doing stuff all the time. So if you want to be with folks pretty much all the time until you fall into bed and get up the next morning and get coffee with people. It's pretty much it's a very social event, and a lot of technical discussions happen in the non-official times of the conference and when people are off doing other things. So it's pretty nonstop.
Great. We hope we can get some new folks up here for it this year, and it's gonna be fun.
Yeah.
Okay, on to Kio. So Flavio, thanks for joining us. Let's see, where do we start? I've got so many things.
I would say my impression, because we went through the docs and tried some experiments and things. My impression is that you're a big fan of Zio, but that it doesn't run fast enough for you. Is that kind of the summary?
What's the motivation?
Yeah, why did you do this?
So I'm always very impressed by Zio and like the way like it is focused on providing better usability, simplifying functional programming, and that's what I've been after for a long time. So if you see my projects, it's always like about like simplifying things, making things safer, and etc.
How do we make safety easier to obtain?
Exactly.
Without the performance trade-offs.
Yeah, and then I always worked on this domain, right? So at Twitter, for example, I worked on the Twitter future. We had a batching library called Stitch that is like Haskell from Haskell and other Zio query as well. And basically, I had like this domain like of trying to optimize these libraries, providing better safety and etc. And I worked on future implementations in open source and Arrow implementation in open source as well. So it's a theme that I've been always exploring for a long time. And seeing Zio to me like was really refreshing to see like the innovation, the focus of the project, and really the power that it brings like with the environment and Arrow channel. But I like to keep like taking new things and like trying to break it up and trying to rearrange it and try to find other ways of encoding things. So Zio, I feel like the fixed two type parameters becomes a bit clunky sometimes, right? So you have all the type aliases that you have to learn, or sometimes you don't need one parameter, you need the other, or any of those, right? So I wanted to see ways of like making that more flexible. So Kyo basically generalizes the mechanism for the effect rotation to have any effects, right? So it's not only environments and error handling. It's really, you can define like arbitrary effects, and it's based on algebraic effects, right? So, um, and that becomes like something that has better usability. That is one of the main focus for Kyo. But to be honest, like my passion is more about performance. So at Nubank, I joined as a performance engineer. I changed teams recently, but like performance has been a focus of mine for a long time. Um, so I worked on these solutions based on arrows. That is basically, if you see the way that we do functional programming with monads, it's really an interpreter, right? So you take like these functions, you keep invoking them and transforming values, but it behaves as interpreter. So each function can, if you have like two functions like map plus one, those two plus ones, if it were like regular Java code, the just time compiler is able to squash two plus two, right? But
Right.
because you are interpreting and calling those functions, they become like a separate unit for optimization on the JVM, and that like defeats many of the optimizations because if you don't inline, like you don't avoid allocations, invocation of the function itself, so there's a lot of overheads for interpretation. And I've
Just like
seen
on the stack and the allocations and all that, the just with everything, when you've got the monadic effect approach, there's a lot of different pieces that you get overhead that algebraic effects may provide a lower cost abstraction.
I wouldn't say that it's more a property of algebraic effects. It's more about this exploration. So if you see interpreters, there is a good way of making interpreters fast. That is the Futurama projections, right? So you can do partial evaluation of codes. So you can have an interpreter that works with good performance. For instance, GraalVM is that, right? So you
Yeah.
build interpreters and it's able to optimize things by projecting and staging the computation, right?
But
In
you
my
have to
early
do some kind of profile based optimization. Like you're profiling something and then applying the that information that you gained in the profile to do your optimizations. Is that
Exactly,
yeah.
yeah. But from a more higher level, right? So it's more about having the interpreter and then trying to partially evaluate the interpreter, right?
Mm.
So how can I make monadic computation to be staged in a way that's going to be optimizable by the just-time compiler? That's
Uh,
the question, right? So my early work on that was arrows. So you can use arrows to basically produce a staged monadic composition, and then you don't need to keep allocating the arrows. You just like pipe values through the arrows,
huh.
right? And at Twitter, we had some performance issues that we solved that way. But arrows are difficult to compose. Like they are, in terms of usability, they are not great. So I wanted to find like other ways of doing this kind of partial evaluation, staging. And in Kyo, what I decided to do is try to use the just-time compiler itself as the staging mechanism, right? So
And I guess in some ways it doesn't make a whole lot of sense to have the JVM being the interpreter for bytecode and have all the JIT optimizations there, and then have another layer of an interpreter for your monadic effects, and then have to eventually recreate many of the same optimizations in that interpreter. Like, why have two layers of interpreters if you can get away with not having it?
So
exactly.
does that mean you have no interpreter in Kyo?
So to achieve that, what I was after is a very minimal car. So basically, if you see the cars of effect systems, they are huge, right? It's a lot of code. Um, and I wanted to find something that was like very small and minimal. So when you are applying, for example, a flat map, a map, a transformation, the implementation of the car can be inlined at the caller.
Huh.
Right.
Okay.
So if you see Kyo's car, go to the car file there. It's 200 lines of code or something.
Huh.
Like a map transformation or effect handling transformation. They are just like 5 lines of code. It's very, very small, right? So
So you don't
um,
need the like separate runtime and interpreter and all that. You're essentially like on a map call. that just becomes, it doesn't have to go through a runtime or interpreter to do that in Q.
Exactly. And even being that way, it still has the properties of effect systems. For example, it's able to preempt computations, pause computations, to have fairness for execution. And a lot of the behaviors that you normally see in cars of effect systems become separate effects, right?
Huh.
So if you see Zeal's car, you have like all the logic for environment, logic for error handling. In Kyo, because of algebraic effects, this small car, you can express environments in a totally separate implementation.
Yeah.
Right? So the environment in Kyo is just like one file with like 20, 30 lines of codes, and it's just that, right? So I think that's also a major difference of Kyo, that is because of algebraic effects, the small car, the composability of effects helps not only the usability on the user side, but also the design of the library itself, because you can have very isolated effects that only handle what they need to handle. They don't need
Yeah.
to think like the environment effect doesn't even know that there is a Bart's effect or any other effect. It's just like its own
Yeah.
isolated implementation, right?
So let's back up a little for people who might not know what an algebraic effect is. How would you define an algebraic effect, or what algebraic effects are?
So let's talk about effects first,
Yes.
because I think
Sure.
there's a lot of confusion, right? So sometimes people talk about effects as saying like side effects, right? So applying something with rotation to the worlds, like something that's observable. But the effect term in the context that I'm talking about, I think it more as like control flow inversion, right? So for example, if you have an abort effect, if you have something that's going to short circuit the computation, it's actually a control flow inversion, right? So at that point of the abort effect, you're going to short circuit the computation, but it's something that is under the hood, right? So for example, users can call like abort and abort a computation at that point, but at that point, like it's just like a suspension. So just saying like, okay, I have this computation, it wants to abort, and eventually the abort effects handling is going to actually handle that computation. And the
With the abort, I think it's a good example because it is giving you an opportunity to change the flow of your program in some way, but not in the imperative or monadic style. In the case of what we'll get into the algebraic effects, so it's something different, and I think that's where effects become hard to define. Is that pure functions are pretty straightforward to define. But what are all the things that are not pure functions that allow you to do a suspend, allow you to essentially throw an error, or do something asynchronous, or all the different things that don't fit in the mold of a pure function? What do we call those things? And there's many different categories of them, and so that's where it gets hard, I think, to come up with like a general definition of effects that's useful. It's like, well, it's kind of just everything that's not a pure function.
I think in Kyo it's easy to reason because you have a suspension of effects saying like I want to abort, I want to get something from the environment, and what Kyo does is just accumulate all continuations, all transformations. So you have the suspension, you can do map, flat map, and you can do many other things. And at some point, a handler you are going to call abort.run, for example, and that's going to be handling the effect. What it is going to get is basically here's the value that was aborted with, like the error that was produced, and here's all the continuation from the points of suspension up to the points where the effect is being handled. And that gives you a lot of freedom, right? So, for example, you
Yeah.
could have, I don't know, maybe a trinary Boolean algebra mechanism, right? So you just like evaluate the true, the false, like, and etc. like within the effect itself, because you have the access to the continuation at that point. And in Kyo, the continuation is a first class value. So it's not, if you see like algebraic effect encodings, normally you have like a magical resume function, something that's a bit opaque. In Kyo, it's just
Yeah.
like a regular function. It's a pure function. You can save it, you can reuse it, or you can have like multi-shot effects as well in Kyo. So
Huh.
it's a very flexible in that sense. And it's simple
Yeah.
as well. Like the car is just like, it's easy to. I would say it's a low-level code, the car, but at the same time, it's quite simple.
You can reason about it in a
Yeah.
way that people can understand. Okay, so effects. We've got effects, and in Kio, you took a little bit different approach from Zio, where you said, okay, instead of constraining you to, which Zio does, to an environment, a result value, and an air channel, you say, hey, anything, whatever you want can be modeled through effects. And sure, you can model environment, result, and airs, but you can also model all sorts of other things. And so maybe give us some of the other things that can be modeled through Kio's effects.
Yeah.
So
So
of course
one
we
effect.
talked about
Mhm.
fibers. We could go into fibers as one example,
Obviously,
but
yeah. But maybe one that is interesting as well is I just renamed lists to sequences in the effect for sequences because it's a really interesting one because you can basically have a computation and then you say, okay, I'm going to get a value out of a sequence. So you have a sequence of integers and you get a computation that has only one integer, right? So you can like basically kind of like a for comprehension, like
yeah,
iterating over the elements. But then you can explore multiple paths, right? So you can use the sequences effect to explore, for example, multiple options that you want to explore. And then at arbitrary points of the computation, you can have like very deep branching and logic and etc. You can arbitrarily drop the current elements,
yeah,
right? So you can explore multiple options and start pruning them according to
huh,
your logic. So you don't need to like work on the collection itself. You have like regular codes where you can have branching and multiple transformations, and at arbitrary points you can drop one element of the sequence that you are handling
huh,
at that point. So it's very, very flexible.
yeah.
That's one example of a different kind of effects that, for instance, Zio doesn't have.
It's real quick
Um,
to stay on that one for a second. Is this kind of like a DSL for like sequence manipulation or something? Like, or have you almost created like something like a embedded DSL for manipulating like almost through like a lens style thing for sequences? Am I getting some of that right, or is this totally different?
I think the perspective is more or less that, but if you see the implementation itself is relatively simple. So if you have a list, you can call sequences.get as in
Uh-huh.
a list. And you get a computation that has the integer, like the value there within the list, and with the list effect pending, right?
Yeah,
And then you
yeah,
can just handle that. So once you handle, you get a list back with everything. But within the computation, you can do map, flat map, you can do branching, if else. And at
yeah,
some point, you can just say, okay, I'm within this computation that has the list effect. Please drop the current element.
yeah,
So it's
yeah.
going to short circuit at that point that specific element and take it out from the computation, from what's
Yeah.
being computed at that point. So
It's
it's very
almost like
flexible.
a like some mechanism using effects for an early return out of some computation on a list. Is
Exactly.
that
It's
yeah?
basically filtering lists with a flexible scope, so you can filter at any point of your computation.
Huh.
Normally, algebraic effect library is called as effect choices.
Huh.
Um,
Okay.
so it's basically like
Selecting
evaluating
choice.
choices and dropping them. But
Okay.
I decided to go with sequences just to have like more intuitive names for people.
Yeah, I like that.
So what makes it algebraic then?
So the pattern of algebraic effects is basically you have an abstract operation where you're suspending an effect that you wanna that needs to be handled. For example, aborting or iterating over a list, for example. At that point, algebraic effects is basically really at algebraic level. So there isn't really an implementation to know how to handle that. It's just like you have an object. Here's the value it was suspended with. Here's the effect it's suspended with, and here's the continuation. That's like just everything that Kills has. The value of the suspension, like the error that was produced or anything, the effect that is going to associate to that value, and then the continuation itself.
Yeah.
So it's really abstract at that point, and you can have effects that cannot be handled because you might not have a handler for it, right? And then at some
Mm.
point you call I decided to go with a high-level API for users, so you call the run method
Mm-hmm.
on effects. So it's by convention, not by interface itself. So when you call run, there's going to be a handler that knows how to handle that effect. So it's going to get the value that it was suspended with, the continuation, and then implement the behavior it wants to have.
It's the run in Kio is like the materialization of the effect plus the state, or the value, the value or function applied to the effect, or the effect applied to the value. Run materializes those things together.
Plus the continuation. So every function has a continuation?
So you get the continuations only when you're handling effects. So, and it's very simple. The mechanism within the car, it's just like at some point of the computation, you suspend with a value, the effect that's being used to do the suspension. And then in the handler, you get the value that was suspended plus the continuations, just like these two basic building blocks.
Yeah. And one thing we didn't dive into is the testing story. Is one of the things that we've done a bit with in Zio is the ability to like provide a non-live implementation of an effect for your tests, and being able to use like test random and feed random predictable random numbers in when you run your test for something like that. Does Kio have any similar ability to like provide different implementations when you're in your unit test versus when you're running on a live system?
Yeah. So if you see, for example, clocks, you can, when you are handling the clock's effects, you can pass the clock implementation if you want to. Or if you're handling the randoms effects, you can pass a random implementation as well. So you can inject things, but it's all based on the environment effects, right? So it's, in that sense, it's similar to Zio.
Okay.
In terms of support for
And then
testing,
the Kio app default, or is that what it's called? Kio app default. That was the only thing we were working with, but that's the place where it gives you the defaults for a running main app
mhm.
in the environment. And I think we dug a little bit into that, where that environment was kind of coming from. So then you would have some spec that would provide different things into the environment when you run your tests. So very
Yeah.
similar to Zio.
So I'm
And
used to
even
continuations
though,
being associated with coroutines, but it doesn't sound like your continuations are for running these functions as coroutines. Is that correct?
so because of the algebraic effects and slicing effects more properly with Q, fibers are a separate effect, right? So because you have access to the continuation, all this mechanism, you can implement green threads and fibers on top of that. And that's what Q does. So if you see the
Cool.
fibers, it's a separate effect, like its own thing. Um, and fibers in Kyo, and that's the area that I had the most experience optimizing systems at Twitter and open source and etc. So I was able to put like a lot of the things I learned over the years there. Something that I felt was an interesting shift in the way that I developed those solutions was joining Nubank and having contacts with Clojure. So
Yeah.
if you see Clojure people, they are really vigorous at like finding the best, simplest abstractions for problems, right?
Yeah.
So seeing that happening like uh, at my job and like seeing the kind of solutions and etc. really inspired me to try to do something similar in Kyo. So in other solutions for fibers, I had like really complex codes, like lots of like more low-level codes. In Kyo, I try to first like make it simple, like, and then after making it simple, try to make it fast, right?
Uh,
So going from a different direction, right? So first simple and then fast. And I felt like the implementation got much better that way. So I think it's not much code and it has like all the properties you expect for a ring thread fiber mechanism. So it has preemption. The preemption in Kyo, other libraries like C or Cats effects, you need to call yield for the fiber to yield to the controller, to the runtime. In
uh,
Kyo, you don't need to do that because Kyo is able to pause the computation on any transformation.
because it's built on the continuation system that is the like foundation of Kio, or
I wouldn't say it's much about the foundation of the car. It's more the async implementation itself. It's not
Okay.
something trivial to do because when you are checking, the computation is running, and then you can have to check if you need to stop the computation, right? So pause the computation. This check is something that you have to do very carefully to make sure you don't hit any cache misses. You have like a code path that's going to be inlined directly into the caller, so methods need to be small. So a lot of my work with just time compilation, I worked on Growl for a while,
Uh-huh.
basically fed into like, okay, I can build like a preemption mechanism that doesn't require corporation, for example, and exploring that. So it's not much about the car, the algebraic
Okay.
effects, more like the fiber implementation itself.
Okay. And is it all green threads, or are you actually using thread pools underneath the covers on the JVM, or how does that work in your fiber implementation?
There's a scheduler. It's scheduler. It has a property that is also different. I worked at Nubank and also at Twitter on solutions to dynamically size the number of threads. Um,
Uh-huh.
and Kyo has, I would say it's a more like basic implementation. We have a much better today at Nubank, for example, but in Kyo there is a at Nubank the solution is like a carefully like designed control mechanism, like all careful things. In
Yeah.
Kyo, I'm trying like a different approach, a simpler one. It is more like a hardwire. I just plug like the signal directly on like the number of threads, so it's a it's simpler than the solution at Nubank. But at the same time, I've seen it has like good properties as well. It seems to work well.
Huh.
So it goes in this theme, right? Okay, how can I make it simpler first and then fast, right? So it's more or less the pattern.
Yeah. But it is using actual JVM threads.
Oh
And
yes, yes.
then what's the story then with the future with Loom and Kio? And have you done any explorations around that?
Yeah, so Loom is very promising. But at the same time, virtual threads, they are not cheap.
Yeah.
Um, so if you see the memory footprint of JVM virtual threads, it's much higher than FX systems in general. Not
Huh.
only Q, it's just like
Huh.
much more memory usage for that.
What's
Um,
what's the reason for that?
if you see the virtual thread class, you're going to see lots of fields there. So there's like a lot of control and etc. So, but I think that's going to be optimized over time, right? So it's
Yeah.
more like the first version. But there is a more fundamental difference between suspensions in Kyo and suspensions by using Loom. That is, when you are suspending in Kyo, you are suspending inline, and once you suspend, you are accumulating the computations that go after, right? So
Okay.
accumulating the continuation. So it's really fast. The JVM is going to just like continue executing, allocating points like for whatever is necessary later to resume the
Yeah.
computation. So you're probably going to have like just, I don't know, 10 flap maps or something like that.
Yeah.
But in Loom, you suspend in a completely different way. That is, you are executing the thread and you suspend by saving all the states that came before. So all the frames that came before,
Yeah.
right? So it's going to copy all the stack and then put in the heap and etc.
I
So
see.
that has much more overheads, right? So especially when you are doing functional programming, you normally have deep nested stacks and lots of temporary values that are within that stack. All of that is going to be holded throughout, like until the virtual threads is resumed and etc. But in Kyo, because you are not suspending based on what came before, you're suspending based on what came later, I think that can have much better performance than virtual threads.
Hmm.
Um, but at the same time, virtual threads are nice because if you are able to block actual threads on the JVM, then you can do better things. For example, I had a Zio integration in Kyo, but wiring the fibers together from Kyo and
Yeah.
Zio plus the effects inside, it's really hard.
Yeah. Yeah.
And I couldn't make something that was like working properly. But if I make Kyo, you depends on Loom and actual blocking threads, then I can handle Kyo's fibers like separate from Zio, and then I can have like an interop that works well, right? So I don't need to uh, block everywhere, but I can block in strategic places using Loom, and that makes usability much better, like integrating with
Yeah.
other systems and etc. It's something I'm planning to explore as well.
Yeah. Nice. Coming back again, so algebraic effects. Let me give my attempt at it. We've got these effects in a system, and we need some way to model how the effects relate and how the computation works when multiple effects are combined together into an execution. And the algebraic part of it is defining kind of the rules or structure for how those effects get lumped together in some way and executed in the right order or applied in the right order or something like that. Is that at all like along the lines of what algebraic effects are about?
Yeah, I think maybe just if you go to Kyo's source code, like reasoning about the concrete primitives, maybe it's easier because the mechanism is very simple. So if you have a computation in Kyo that is using the greater sign, we are calling it the pending type now. It's something that
What's the
someone
word for that?
pending. So pending,
Pending.
if you have integer pending options or integer pending fibers.
I was actually going to ask you what you called that operator because okay, so in Kyo you say like some
it's part of the type definition.
Part of the type
somehow.
definition, and the effects come after that,
after the greater than,
and are anded together. But I was going to ask you what you called that because I think we were like, do we say string applies fibers, string needs fibers, string, like we were looking for the terminology there. So the terminology you're using is pending to say that, to convey that to get your string, you have these pending effects to be applied with your thing to get to the string. Am I understanding that terminology?
Exactly, yeah. It's someone when I designed and like chose the symbol itself, it was based on like earlier versions with a different design. So I didn't even think of a name. It was more abstract to me. But someone on Discord suggested it, and I love it because it reads perfectly, right? So it's in the same position as you were saying, and etc. So it works pretty well. But I think we were discussing something else before I lost.
So about algebraic effects. So we would say that I want this value, but I'm pending the application of these effects that are anded together. They're product typed essentially together, and the algebraic part of this is describing the relationship between how those effects that are pending are the relationship between them and the thing that we're applying them to. Is that?
Yeah, so internally, pending computation, something with the greater sign, right? So a Kyo computation, it has only two possibilities of state. One is it's a pure value. So if you have like a integer with pending options, for example, internally it can be just an integer. So it might not be actually with that suspension of the effect. So you can have effects that are declared, but they are not in the computation. So, but internally, Kyo doesn't have any boxing, and that's one of the things that make it have better performance. So if you have a pure value, it's just the value itself. But if you have a value that's actually something that has a pending effect, it's just like a triple. So it's basically the value you suspended the effect with, for example, the error or anything depending on the effect, the name of the effect, so the tagging of which effect has that value, because we can have different effects using options, for example, right? So multiple effects with the same kind of value. So that's why you have the value itself plus like a tagging of the effect, and then a continuation. And once you are, for example, doing a map or flat map, that's just appending one more step to the continuation.
Yep. Yeah.
Right. So, and it keeps doing that until you reach a handling of an effect that matches the tag that is there. Right. So it's a very, in terms of like the inner mechanism, it's quite simple. But at the same time, I see that it's a very abstract at the same time.
Yeah.
So maybe
would you
looking
say
at the
that
concrete implementation makes more easier.
Would you say that structure of appending things, finding the named thing, combining it with the continuation and the pending value, like that is the algebra or the algebraic piece to this. Like that's what makes it algebraic effects versus monadic effects or some other type of
I
effects.
assume that's the contrast that you're saying is like, okay, monadic versus algebraic.
But at the same time, it's a monad as well, right? So the pending type is a monad. So
it's the
it's an encoding
Schrodinger's
of
cat of
algebraic
effect
effects.
systems.
Yeah. So it's an encoding of algebraic effects in a monad, right? Because monads are great. You can implement anything. Like you can take a JVM without async, and you can put async in it because you have like the power of controlling the control flow. That is the thing with like inverting the control flow with effects, right? So it's basically a monad, and it's interesting because there's probably like some discussions. Oh, is Q like a monad or anything? But it's a monad by construction, right? So if you see the definition of flat map in Q, there is only map actually. There's like the simplification. It's just like the definition of a monad itself, right? So accumulating the transformation. So
it's like particle and wave. It's both. It depends on how you look at it.
Right. So you're saying that you're still using monads, but they're hidden to the from the programmer. So it makes it easier
if the programmer wants them to be hidden.
Well, so what we were looking at, where you say, okay, have the result and then pending, and then here are the effects. You're saying that under the covers becomes a monad, right? Okay.
Yeah. So
and you can use in a for comprehension, which I don't think we even tried, but it is possible because they are also monads.
Mm-hmm.
We were only using the direct style. We're big fans of the direct style.
Yeah, we're very glad that you adopted that. Yeah, because that makes it so much easier to think about.
So I think that's part of the interesting thing is that you can use it as a monad, or you can not. You can use it as the pending types and direct syntax or whatever.
Okay. And the reason, so taking a step back again, it seems like the reason that we're doing all of this is to be able to compose functions.
Is it all ultimately about composability?
It seems like it.
I think so, and it's a composability at a deeper level, I would say. So if you see, for example, language features like implicits, right? So what you are doing there, you are injecting something. The equivalent is an environment effect, right? So there are many constructs in language that are basically native to languages that you can actually express by using algebraic effects, right?
Abort
so that's
and tries, right?
Being
exception.
Yeah. But you can do that in a way that you don't tie to a specific implementation. You can provide different handlers, so you can make something more flexible, right? So I do believe that algebraic effects within a language itself could be like more native, could be like a way of like getting rid of a lot of complexity that, for example, Scala has, because you can encode things as effects, right? So I've been exploring languages and building working on languages and implementing. So it's something eventually in the future I'm planning to work on. So trying to define a new language.
Yeah. Have you looked at the Rock?
Yeah, I was just going to say with Unison and Rock, it's interesting that both of them have adopted algebraic effects and
as first class
things.
Components, yes.
But what a great way to be able to say, here's your pure functions. Here's the rest of the stuff. And the rest of the stuff is not constrained to the things that we want to support in the language. So I think a good example of this is async and suspend functions, async await, like all that. Like, sure, you can have a language construct for async, but then what about environment? Then should you have a language construct for doing dependency injection? Should you have, and the list just goes on and on and on, and we continue to evolve the things that we want from our language. And I think maybe the huge opportunity with algebraic effects is to say, instead of evolving the language, you evolve the algebraic effects, because that gives you the foundation to be able to have something that can expand to whatever you may need.
Hmm. Exactly. I think that's a amazing design space. I would expect that the languages and like function programming is probably going to converge to that. If you see like other languages, function programming in general, like it's pretty strong on algebraic effects. So I think there's a lot of possibility and potential there.
Yeah, that's exciting.
So how would you define composability or composition?
Oh yeah, it's all about composability. That's where we were going.
That's kind of where we're going.
So for a long time, Twitter, we used to use futures, right? So they were strict, not really functional, and etc. And I couldn't really see the benefits of like going purely functional and etc. because especially of the complexities around like having lots of concepts, like I don't know, things from category theory or like all the complexities around those solutions. But with Kyo, I'm really seeing the value of having composability because once you have composability, you are basically you have a proper foundation to do inversion of control flow. For example, implementing algebraic effects, right? So in Kyo, I've been the module that I'm using the most is one that I haven't documented yet. It's a large language model integration.
We did want to get to that, so we want to hear more. But yeah, keep going with your current.
And because of the composability, I can build abstractions that are just much better than what you see in other libraries, right? So, for example, when you are dealing with large language models, you have the problem of the context size, right? So some people think like, oh, now we have large context. It's not true because like large contexts have a lot of drawbacks, like the quality of the completion drops a lot, and etc. So managing the context size is something complicated. So in Kyo, because I have effects, it's very easy to build those effects. I have mechanisms to do transactions, like transactional behavior for large language models within their context. So for example, you are like in a large language model, you are like in an execution with a user, and you want to perform some subtask, right? So you are going to, I don't know, call a database and get some data, summarize, and etc. And then eventually you are going to come back. You can use like a transaction for that subtask, and then it's going to basically roll back the context to the start of that subtask, for example, right? So
Yeah.
it's a kind of behavior that once you have composability, the code's like pure and etc., you can like build abstractions that are just so much more powerful than normally like regular libraries have.
Huh. So the composability, you're saying yes. Pure functions we know compose, like that's pretty obvious. There's other approaches that you can get to usable composability. We were exploring last night for our book how painful the world of pre-Zio and pre-Cats kind of was, where and I'm sure experienced this at Twitter, where it's like, okay, I've got a future, and now anything that I touch needs to get transformed into a future. And I'm sure you lived through that, like monad transformer, like just the pain of all that. Or like I've got an option, why do I need to like put an option into a future? Like that doesn't, like turn an option into a future, like that's just silly. But you have to do it to be able to get the things together. And so Zio says, take all your structures and turn them all into Zios, the like Uber monad approach. But maybe algebraic effects provides us a non-Uber monad approach to do composability of these effect things,
Exactly.
non-pure things.
Yeah, and not necessarily non-pure because if you see the environment effect, it's pure, right? So it's just function composition as
Yeah.
well. If you
Yeah.
see the implementation itself, but at the same time, like you have to design effects well, right? So it's easy to design effects like that, just like loops forever, or has some property that is like not pure, right? So the designing of effects is something important to do well as well, but like you said, like composability, being able to compose things and at the level of effect, it's really, really powerful. the way that I'm using Go is more like with a large language model. So I'm using it like a Uber monads for a large language model because it have like just the AI's effects with everything I want to use. But there are some rough edges in Go still. For example, if you are forking a computation, there is this problem, right? So in Zio, it's easy for it to fork a computation because it knows like it might be aborted with like failure, or it has to save all the environmental values from the place that's forking to the forked
Yeah.
fiber. But then in Kyo, you have an unbounded set of effects,
Right.
right? So how can you make that pipe through like when you're forking the computation? And
Yeah.
so I've been thinking of ways of solving that. Right now, users have to handle effects. So if you have like I don't know, a list effect, you handle the list effect, you get the list, fork that computation that's going to produce the list, and then you get back a list, and then you suspend again. So you have to manually do that wiring. But I'm
This
exploring
is
ways of like providing better usability for that use case.
this is actually one of the things that I was going to ask you about was in Zio. One of the cool things is because it has the air channel as part of the structure, you can do something like a collect all successes par, where it's going to do this stuff in parallel, but then only return you back the ones that were successful. And I was curious in Kia if you'd had any thought about how you would do something like a collect all successes par, because you've got fibers and you've got, let's say, aborts. How do you would you need another effect that could essentially know how fibers and aborts could work together to create a collect all successes par, or is this the area that you're saying you're still trying to figure out
Um,
some pieces too?
For this kind of pattern, a lot of the async primitives in Kyo are inspired by the Twitter libraries because that was like something I worked a lot on. Um, so you can basically like handle things like if you are aborting, you can basically. Sorry, I missed the train of thought. Sorry. Maybe
Yeah,
if you
so
can
I
repeat
think
that.
it's like if you've got in Keo, you've got fibers and you've got aborts. How would you create something that essentially compose them together into something like Zio's collect all successes par?
Oh yeah,
And
sure, sorry. Yeah. So in Twitter futures, we normally use lifting to try. So you basically instead of just forking the computation without handling of tries, you just like handle the tries effect, and then you
uh,
get a list of tries, and then you can easily unpack that, right? Um, so that's one way of doing that. So, but you are doing racing of only successes, but you want all the successes, right?
Yeah, and then
yeah,
you have to
Okay.
know, it has to know what a success is.
hmm But then it's just really try. So you can do, you can take your list, map it, saying tries.run. You're going to get a computation that returns a try. And then you call parallel on that
yeah,
list. And then you get a list of tries. And then you can make the filtering at that point.
nice. Okay, we'll have to explore that.
Mhm.
That'll be fun. Okay, a couple other Keo specific questions, and then I want to go to the LLM stuff. So as we were exploring things, there was one thing that we found that was I don't know, a little weird, and I just want to ask you about it. Was um, it's possible if you call, let's say, consoles.println, and that returns a unit um, pending consoles. That's all correct, right?
Yeah.
uh, but if you we at one point discovered, maybe accidentally, that you can set the return type explicitly of that to just unit, and then you lose the pending consoles part. And I think that's
hmm
just based on Scala's, the way that unit works in Scala's type system. Because we couldn't do the same thing for something that didn't return a unit. Like it would be a compile error. So I was just curious,
hmm
like maybe we were doing something wrong, or maybe that's just a limitation with Scala's unit type or something
Yeah.
like that.
So in Scala 2, we had the warning on non-unit discarded values. I think in Scala 3, there isn't, or maybe it's been introduced. That would be a case for the compiler to say, okay, you have an actual value here and you are returning a unit, you're just discarding an actual value, right? So Scala 2
Yeah.
should would work fine, but I don't know in Scala 3 how it is.
We'll explore the warning options to see if we can get a warning for that. That'd be interesting. And then the other one was we also discovered something that I didn't fully understand the reasoning behind, which is that things like consoles are pending consoles, but things like random and clock are pending IOs, and we weren't totally sure why some things were pending its own type and other things were pending on the IO's type.
Yeah. So one thing that I think is a problem for a solution like Kyo is the growth of effects and the pending set of effects. I think that for usability can become a major problem, right? So you have newcomers, you're going to see like lots of effects. It's hard for people to reason about. So that's a design change I made right before the release, that some effects I thought weren't worth tracking at the type level. Right? So if you are using clocks, like you want to be able to inject a clock, but do you want to really track that you are actually using a clock? I'm not sure, but I think that's something that can be evolved, right, with the community and etc. But I try to, before the release, reduce the number of tracked effects to avoid having like all the issues in terms of usability. So, for example, consoles is one that I personally want to know if a computation uses the console, right?
Yeah,
because
that's why you make it its own effect versus it being just the IOs.
Exactly.
Yeah, interesting. I guess this is kind of similar to what Zio did, where they ended up taking clock and random and console and taking them out of being in the environment into being essentially in like the Zio system environment or something like that, because it just got like too silly to like have all of your type definitions have an environment of consoles with clock, with random, with like it's like all these commonly used services, just make them go away essentially. And so it sounds like maybe that was some of the motivation for putting some of these like very common system services into just a standard IO's effect.
Something I don't like about Kyo's design now is how IOs is everywhere, right? So, but IOs is now basically like the main effect within the library, and it models side effects plus deferring computations and etc. And for large language models, there's a problem of sandboxing of code executed by large language models, right? If you are able to express the constraints of not being able to do side effects, you can more easily trust code coming from a large language model, right? So, or you can more selectively say you're going to have access to this kind of service, or you can perform side effects or not, you can use fibers or not. I think that can be a good way of interacting code bases that are both maintained by large language models and humans, right? So having ways of like having more clear boundaries. So eventually I want to try to have more like IO and hygiene of the library. So only where you're actually doing side effects, you're going to have it. Otherwise, you wouldn't have it as well.
I hadn't thought about the relationship between code generated by LLMs and the need for defining the side effects or knowing the possible side effects. Bruce and I were talking recently about how if your large language model can most of the time give you the code that you would write anyways, then why does that code even have to exist in the code base? And if you combine that with this idea of, and if we can constrain the code coming from the large language model to only certain effects, then that gives us even better kind of certainty that the code that is coming from the large language model is going to be safely executed in some way. So there's probably some interesting things there. As a total side tangent, I'm seeing like a similar evolution happen in the world of WASM and the WASM component model. This idea that your core WASM is effectless, and then the WASM component model is where you can plug in the actual effects. your WASM expresses the effects that it needs. And if you were to take this WASM and run it on the cloud, the effectful pieces can be replaced by whatever the cloud provider wants to do, its own logging thing or whatever. And so I think there's this shift happening where, as we are able to describe systems, the effects of that systems require, then we can do all this other cool stuff around them, whether it's like protecting code from large language models or running on a cloud environment or whatever it may be. But that like separation between effectless and effectful effect pieces is foundational to being able to do some of this cooler stuff. So tell us more about what you've been exploring with large language models. I'm interested to hear more.
Yeah, so something that I think is going to be a tendency for the future is maybe large language models are going to hit a wall in terms of capacity or what they can do. I believe that another dimension that large language models can evolve and scale to is coding, right? So instead of like having just like this simple interaction, make a request to the large language model, get a response, right? So allowing the large language model to have codes around it that's going to be encoding behaviors, allowing it to like even self code itself, like these kind of solutions is what I've been like trying to explore in my free time.
Yeah.
And at work, I've been doing more like work, basically like indexing large volumes of data, uh, building knowledge graphs, searching that data. And it's really cool to use like Q and like the more advanced features because I'm able to build like pipelines of like going through like a lot of data and then bringing like meaningful information at the end and etc. So it's been really nice. I like to keep like changing areas to work on different things, and large language models, it's just like so much, so a lot to learn and do. Right?
Yeah, we're wondering if you might be considering, instead of making massive amounts of documentation, simply creating a large language model that will be able to describe Kio, and then you could just ask
Yes.
questions.
I think I'd seen a tweet from you where you're kind of exploring like how do you make your own Kio large language model so that people like us can learn it more easily. And
I have to say, I mean, I started learning Rust, and then ChatGPT came along when I was a good portion of the way through, learning all the keywords. But all of a sudden, it just accelerated my learning because I could say, write a program to do this thing I'm interested in right now, and then I'm really focused on how it does it. Whereas if it's just some example that you came up with because you thought it would be illuminating, it's not nearly as interesting to me. And so if I could ask the Kio LLM to write a program to do this and then study it, that's just going to dramatically increase my. And then also, if I don't understand something, if I can say, well, why is this pending thing behaving this way or whatever, and it explains it. It's just, I would say, in terms of language acceptance, that's just going to bootstrap
to learn new
people.
technology.
Oh, yeah.
It's like anytime somebody needs to learn new technology, ship your LLM with it.
Mm-hmm.
So what's
Or
tell us
even
more about what you've been exploring on this front?
or even, for example, migrations, right? So you have a new version of your language, your library. Just hit a large language model that does the conversion, right? Or
Yes. Yes.
even error handling and providing better usability for when users make mistakes. It's a really interesting area. So yeah, it's what I'm doing at my day jobs. I'm learning a lot there. And I'm also going to be exploring in Kyo. The next big thing for Kyo, the two next big things, one is better usability for forking computations, handling effects. And the second one is the Copilot, so building a Copilot for Kyo. I want to explore some more like uh, unorthodox approaches to build that. So just to have like learning and try to build different things. But eventually, there's like techniques today that you can use, like retrieval augmented generation, etc. That also works. But yeah, I'm going to try like other things before just going with the traditional.
Nice. Cool. Well, I look forward to seeing more on that from you because we've been trying to figure out like how to use LLMs with the book we've been writing, and have been somewhat unimpressed with the current state of LLM stuff. So maybe if you can,
and I think some of
create
that
something
is
for
just
us.
because it doesn't have enough. Maybe it doesn't have enough ZO2 examples.
Oh,
and
that's
Scala
for
3
sure. Part of
examples,
it is
because my experience using it with Python has been quite impressive. So
if we're like,
Yeah.
give us this code in ZO2 with Scala 3.3 with no braces syntax with ZO Direct. ChatGPT is like, I didn't understand most of what you just said.
Yeah.
So we've not been able to get very much
not
use in
really
our book stuff
much, no.
out of LLMs. But if Scala and Zio have shipped LLMs for, and if we could combine those LLMs somehow. But,
yeah, I just read something this morning about small language models. And I think
why didn't they go with micro though? Because that would have fit so well with microservices.
Well, I think it contrasts large, small, but I think the idea is that your language model only understands a particular topic. I think that's what a small language model is.
That makes sense.
So it's kind of what we're talking about here. So there's one more question that has been unclear to me, which is that, okay, when you've got a Keo function, it is got concurrency. It's a coroutine. Is that correct? All Keo functions are coroutines because they have the continuation attached.
Coroutine is more about asynchronicity, so it's only a coroutine when you use the fibers effect.
So you actually
without
have
fibers,
okay.
Without fibers, you're just executing within that threads. There is nothing besides the handling of effects there. So
it's all synchronous.
It's when you use fibers that you get to.
Okay, so you have to explicitly use fibers, whereas in Zio, I think everything is running as coroutines.
Well, Zio executes a lot in the current threads as well. It has even optimizations for that. So in terms of execution, it's not very different from Kyo.
But it's all every execution in Zio goes through their scheduler, and I think what you're saying is that in Keo, the only time you're going to go through the fiber scheduler, your Keo fiber scheduler, is if you're actually using fibers.
If you create fibers.
No, in Zio, if you run a computation, if I'm not mistaken, it's going to use the current threads. It's not necessarily always going to use and fork to the.
But it can suspend and resume those functions.
Yes. So maybe I think we can call the continuation mechanism also a coroutine mechanism, because coroutines don't need to be about asynchronicity, right? So it's more about manipulating computations and like being able to resume them and like, so yeah, maybe we can call like even without fibers coroutines as well.
Okay. Yeah, well, I mean, the way Python works is it only runs one thing at a time, but then it suspends and resumes them, so everything tends to move forward more quickly. So, yeah, I think that's fair to say.
Yeah.
Even Kyo has support for JavaScript using Scala.js, and there's only one thread, right? So but it's the same mechanism.
Yeah. Okay.
One last question. Tell us about the origin of the name Kyo.
Yeah, so I was born in a Buddhist Buddhist organization, right? So that is my religion. I'm not really active nowadays, but it's basically the last character of the mantra of the religion. So yeah, that's basically the source and the meaning. So there's the Shakyamuni Buddha, that is the original, like the historic Buddha, and he has like many teachings, and each teaching is called a sutra. That is like a name for a teaching of the Buddha. And Kyo is basically like the Japanese version of sutra. So that's the meaning. The deeper meaning is more like the threads that basically are the basis of our reality. So basically like the what's like beneath everything, right? So that's more or less the meaning. Yeah.
So reality's run by threads?
No,
colors.
algebraic effects, actually.
Oh, okay.
Yeah. The threads of reality is algebraic effects.
And so it's just a coincidence that Kyo and Zio rhyme.
Yes, it's a big coincidence. Yes.
That is funny. I don't think we'd realize.
My brain is not very about sound, so I didn't even think like much about that, or even like the pending type now. It was just more symbolic for
I
me.
read into it when I was looking at the docs. I read into it that because you kept saying, "Oh, Zio is great here and there," and then we've got this thing called Kyo. I just assumed there was some sort of a connection there.
Well, and I think there is a lot of homage to Zio that is, I'm sure the Zio folks appreciate. And I don't know if John's made any particular statements about Kyo, but you said recently you were exploring some quill related things for Kyo, and so I guess as a background, we've talked about Zio a lot on this podcast, and I'm a big fan of Zio and a lot of stuff they do, but always wondering like what's next, And to me, like what you've done with Kyo illustrated a lot of these, like, okay, there's some things that maybe could be better, or at least some experiments that we can do to see if we can help push things forward in certain ways. And so I appreciate all your work. It seems like this has been a labor of love for what seems like many years working on this. And so I'm always thrilled to see like things that try to make things better for developers, make the happy path the easy path. And so it's been cool to see what you've done there. So thank you for sharing it with us, and I'm sure it's been a journey.
Yes, thank you so much. I'm super excited with the project, and I'm hoping to attract new contributors as well. So if you are interested, reach out and etc. I want to focus on the co-pilot because I think that's something that's a big differential once there is a co-pilot for adoption. So that's going to be my main focus. But like library needs like integration for databases. So I'm thinking Quail, like lots of other things that those systems normally have, FX systems. So they all need to be built, and there is a lot of opportunity for people to come and join and collaborate. So
that's awesome. Good. Well, hopefully you can get in touch and make the world of Kyo better and wider for everyone. So.
And how did people find this on the web?
What's your website? Getkyo.something?
Getkyo.io, yes. That's the website, and it's on GitHub as well, getkyo/Kyo.
Cool.
And Kyo is KYO.
Good thing to clarify.
Yes.
Yeah. Right. Yeah. Awesome. Anything else, Flavio?
I think that's it. Thank you so much, and it's been great to listen your podcast for a long time, and now talking to you as well.
We really appreciate having you on to talk about Kyo.
Thanks for everything.
Hey.